So now that we understand the basic principles of light, we're going to go ahead and apply them. And we're going to start with one of the easier ways to apply them. We're going to apply them in something called a plane mirror. So a plane mirror simply just means a flat mirror. That's the type of mirror that you would be used to looking in your bedroom or bathroom. Any sort of flat mirror where you essentially look like you. So a little bit about when you actually look in a mirror. When your eyes detect light in a plane mirror, you actually interpret the object to be behind the mirror. So when you're actually looking into a mirror, it looks like you, to your eyes and to your brain, it looks like you're actually standing behind the mirror. So it looks like you're the exact same depth as you would be behind the mirror. We actually call this a virtual image. So we're going to be looking at two different types of images. This is the first type of image. It's called a virtual image. Why do we call this a virtual image? Because the light does not actually reach behind the mirror. So even though it looks like you're standing in the mirror, even though it looks like you're standing behind the mirror, remember there's actually no light coming from behind the mirror. Mirrors are totally opaque, as we know, as you watched in the video that's posted below. Mirrors are totally opaque, so there's actually no light coming from behind the mirror. It can't pass through. This means that the light is coming from what we call an apparent light source. So the light that's causing the image is coming from an apparent light source. It's almost like tricking your brain. Your brain thinks the light is coming from that source, but it's actually not. So this is an overview of an image I'm going to draw with you now, and it's how mirrors work. So you have an object, and that object has light rays coming off of it. So whatever the object is, it has light rays coming off of it. That light ray is hitting the mirror, and it's bouncing back, and it's entering your eye. Remember, it's hitting a mirror and bouncing back, where the angle of incidence, the angle at which it hits at, is going to be equal to the angle of reflection, the angle at which it's reflected back at. However, when you see the image, again, the image looks like it's a reflection of you. It's standing over here. So notice here that we have these dotted lines. That's that apparent light I was talking about. When your eye sees that light reflected back into it, your eye is tricked. Your eye knows that light moves in straight lines. Your eye doesn't think that this is hitting a surface and reflecting off of it. So your eye just makes the assumption that the light source is actually coming somewhere from back here. Notice this is a big straight line. And again, we know that light travels in straight lines. So your brain goes ahead and assumes that the image is coming somewhere from behind the mirror. So we use light rays and the laws of reflection to show how plane mirrors produce a virtual image and where it's located. So I'm going to go ahead and I'm going to show you now how we can actually do this in a diagram where we can actually predict, using those light rays, where an image is going to be located. So the first thing I need to do is I need to start with a mirror. So I've got my mirror here. Remember that no light is actually going to pass through my mirror. Everything is going to be reflected. I also have my object. I picked a really simple object in this case. It's easier to talk about simple objects. What I did though is I picked an object that has very distinct corners, so that way it's easier for you to see the shape of what the object is going to be. We also have yourself, your eyes, because remember, light is going to be leaving the object, it's going to be reflecting off the mirror, and it's going to be entering your eyes. So now we notice we have our first incident ray. That incident ray is traveling in a straight line, and we can see the arrowhead here. It's hitting this mirror. We know as soon as it hits this mirror, it's actually going to be reflected, and it's going to be reflected at the exact same angle. So if we were to draw a normal in here, a perpendicular, we would find that this angle of incidence is going to be equal to the angle of reflection. Now what your eyes see is it sees a light ray traveling from this direction, hitting your eyes. Again, your eyes aren't going to assume that there's anything in the way here. So what your eyes think is there's an apparent light source. Your eyes think that this light ray must be coming from somewhere back here. Now, why are the light rays behind the mirror dashes? They're behind the mirror as dashes because they're not really there. That's an apparent light source. These light sources are actually there. This is just what your eyes or your brain thinks. So we draw them with dashes because it's an apparent light source. They don't really exist. Okay, let's get ourselves another incident ray. So notice I drew an incident ray from this corner this time. And what's going to happen is we have our angle of incidence, and then we're going to have our angle of reflection. So this light ray is going to go ahead and it's going to bounce off, and it's also going to hit your eye. So notice they're actually converging when they hit your eye. Now again, your brain is going to think that this straight line here is traveling from this general direction. So we're going to see another apparent light source. You can now start to see the rough edges of where the object is going to be, right? We have our two light rays here, and we have our two sides of our object here. So you can see how your brain is going to go ahead and interpret, and your brain is going to think that where'd it go? Your brain's going to think that the object is going to be here. So notice that we added one more light ray. It entered your eye. We direct the apparent light ray, and your brain is going to interpret the image is somewhere here. So again, in a plane mirror, your brain thinks that the image is opposite of the object. And notice that it's actually flipped. This right-hand side of the star actually is the left-hand side of the star in this case. So again, when you wave at yourself in the mirror, your right hand actually looks like your image is left hand. So it explains why we get that flip in mirrors as well too. So now that we know that, think about the word ambulance and why the word ambulance is actually written backwards on any ambulance. You might not have noticed that. Next time you see an ambulance, look at it head on, and you're going to see this word ambulance is written backwards. That's because mirrors flip everything. So if you're driving and you look in your rearview mirror, you're actually going to see this word ambulance, and it's going to read ambulance. So that's one way that we've actually been using what we know about mirrors to our advantage. Let's talk a little bit more about images. So I'm going to remind you what an image is. An image is a copy of an object through the use of light. We want to go ahead and we want to describe an image. So we've come up with 4 characteristics of an image. These characteristics can be known as SALT. So we use the short form SALT to describe the characteristics of an object. So of an image. So when we're trying to compare an image to an object and decide if it looks the same or if it looks different, we describe the image using SALT. The S in SALT stands for the size. So the size of the image compared to the normal object. So when you think about those 2 stars, the 2 sizes seem to be the same. When you actually look at yourself in the mirror, you don't look shorter, you don't look taller. The sizes appear to be the same. So we really have 3 descriptors for size: same, or you can sometimes look bigger, or you can sometimes look smaller. I'm sure you can think of an example that you've looked in a mirror and you might look bigger or smaller or distorted. That comes from curved mirrors, and that's what we're going to talk about next. The A we call attitude. All attitude means is it upright or is it inverted? So again, when you look in a mirror, you're standing straight up, you're upright, so we call that upright. If you ever look in a mirror and you look upside down, then that's considered to be inverted. If you're not sure if you've seen this before, what I want you to do quickly is I want you to go grab a spoon. I want you to look in the back of the spoon really quickly, move that spoon backwards and forwards from your face, and you're going to see that for part of that that reflection, you actually appear inverted. You appear to be upside down in that spoon. So attitude, the 2 ways to describe attitude: upright or inverted. The L stands for location. So this is the actual location of the image. Before, we were talking about something that's behind the mirror. So we said that every time you look in a plane mirror, a flat mirror, it appears like you're standing actually behind the mirror. There are some images that appear that we're in front of the mirror. We're going to talk about those next, and we can actually even get a little bit more specific. I'm going to show you how to calculate this. You can actually calculate how far that image is actually going to appear from the mirror. And finally, we've got the T in SALT is type, and that's just going to be real or virtual. We already said that we've been looking at virtual images so far when we've been looking at plane mirrors. We've been looking at images that are caused by apparent light sources. Now we're going to switch to looking at curved mirrors, and curved mirrors are going to introduce the idea of the real image. So as we introduce curved images, which is going to be our next lesson, I want you to keep in mind SALT, because every time we locate an image, I'm going to ask you to describe what it looks like. What's the size? What's the attitude? What's the location? And what's the type? SALT. Now let's just give you a quick definition of a real image because we're going to be looking at some of those next. A real image is an image that's formed when reflected rays meet. So remember the last image we were looking at, reflected rays were never meeting. They were never crossing. We were dealing only with apparent rays. You can have some cases where reflected rays are actually going to converge or meet. I'm going to show you this in a lab that we do. A real image can be seen on a screen due to the light rays arriving at the same image location. So you've actually seen real images before. Anytime that you go to the movies and you are looking at the images on the movie screen, those are actually examples of real images. Real images are able to be projected onto a screen. Virtual images are coming from rays that appear or apparent light sources to be in a certain position, but are not actually there. So virtual images are caused by apparent light sources. It's imagined. So again, your brain is imagining you standing behind the mirror. Because they're coming from apparent light sources and light sources aren't actually converging, they're not able to be projected. So anytime that you're trying to reflect an image or create an image from a plane mirror, you're not able to actually project that image on a screen. So now that we know what plane mirrors look like, that's a little simple idea of how light rays can reflect and cause an image. We're going to kind of get a little bit more complicated here. We're going to go ahead and look at what happens when we bounce light off of a curved mirror.